Right. Hello, good morning, and welcome to our class again. In this session of the class, we will be looking at how to use Newton-Raphson method to find root of real value functions. Um, yeah, most time we encounter difficult functions that not be, you can't just get the value of its root just directly like that. A couple of functions that you cannot just get the value like that using algebraical method. So when you encounter something like that, so most people feel discouraged and don't know what to do anymore. So they ignore the problem and want to move on. So in this session, I'm going to introduce one of the methods that can be used to find the root of such a function. Now, but it's not as if Newton-Raphson method is the absolute or the only method. There are methods, but this one will help you to do a whole lot of good things for yourself for the start. So during this method, there's some limitation, though. The limitation only comes if you don't know how to differentiate. If you don't know how to differentiate, that will be very difficult for you to do. And also, it requires guessing the face value. The face value is always guessed. So if you get the value that's very far from the solution itself, it will also make your work, the iteration to take time. So Newton-Raphson method is an iteration method of finding the root of a function. Okay, so let's get straight to the business. But before then, don't forget to subscribe to my channel, please, if you've not done that, because we will having a couple of good stuff coming like this in the upcoming lesson. Okay. We again don't fail to subscribe to the channel. Thank you. All right. If you have any question in any of my videos, please don't fail to drop it on my comment section. I really appreciate it. It will help me to do better for you and then approximately do the right thing for you and know the direction to follow. Okay. All right, let's get straight to the business. So the iteration formula for Newton-Raphson method is iteration formula for Newton-Raphson method is given by xn plus 1 equals to xn minus f of xn all over f prime of xn. Okay, remember who gets the first value, x naught. So, for example, how do we use this? After guessing x naught, you consider the next value you're supposed to find is x1. So, and that means x naught plus 1, I'm trying to show you how to apply the formula, will be equals to x naught minus the functional value of the x naught all over the derivative value of the x naught. So that's how to use it. So if you want to find x2, that means the initial value will be the x1 value. So that is how the iteration goes until you meet a result such that you check that the absolute value of xn plus 1 minus xn is less than the epsilon value, assuming I guess my epsilon value to be 0.001. That means at 3 decimal places, I should have a value that is tending to 0. The value must be almost tending to 0 while checking. So when you have that at the dimension of check, then once you get to that position where the iteration value where the current value and the previous value is almost zero or tends to the value of the epsilon. So we stop the iteration and then know that that value is the approximate value or solutions of that given problem. All right, let's get straight to the business. So I would like to use the example. Let's say f of x is a function x to the power of 4 minus 2x to the power of 3 minus 3x to the power of 2, then plus 4. Then, like I said, you will need the derivative. So f prime of x, this will be equals to 4x cubed minus 6x squared minus 6x, then plus 0, because this is derivative of a constant. Then we will get the first guess value. Guess value, let's call that value x0, like x0. I want to guess x to be equals to 4. So if my guess value equals to 4, I will get my functional value at x0. F of x0 will be equals to f of 4, and that equals to, if you do the substitution, that will be 4 to the power of 4 minus 2 into 4 to the power of 3, then minus 3 into x, minus x, all right, to the power, to 4, then plus 4, that is 4 squared plus 4. And if you evaluate that, you have 84. And also, we will have f prime of x0, which is the same thing as f prime of 4, which is equals to 4 into 4 raised to the power of 3 minus 6 into 4 raised to the power of 2 minus 6 into 4. And that will give you 136. Now we can substitute that since it is x0, let's get x1 from the iteration formula stated earlier. X1 will be equals to x0 minus f of x0 divided by f prime of x0. So substituting, you will have 4 minus 84 divided by 136. So if you evaluate that, you get 3.3, or I want to keep it in 4 decimal places, 3.3824. Okay. So we move to the next one. You have now the value of our x1 is known. So we want to check if, because if you check, I've set my epsilon value. I think later my epsilon value, I will stop at where my epsilon value at my xn plus 1 minus xn will be less than 0.00 and 1. Okay. So, okay. So, of course, if you do this minus this, just check it, absolute value of 3.3824 minus 4 will be not less than that value. So that will not be less than that value. It's not less than that, my epsilon. So I will continue. So I'll take the next. So let's try the x2. X2 will be equals to x1 minus f of x1 divided by f prime of x1. So, but if you check the substitution, f of x1 is going to be equals to, if you substitute that, you have Well, 23 point. I want to take point 4 decimal places, 1, 7, and 2, 5. Then I'll also get my f prime of x1 that will be equals to um let's check my work there. All right, so that gives me 65.8490. So substituting it into the function, you have that x2 will be equals to the x1 value 3.3824 minus you have f that is 23.1725 divided by 65.8490 approximately equals to, so if you do that, you will have 3.0305. Also, you try to check that absolute value of the x2 minus x1 is not less than my epsilon value, which is 0.001. You can try that this minus that value, this will not give you that. So we'll now move to the next one. So x3 will be equals to x2. We update the value. Okay, x2 minus f of x2 over f prime of x2. Okay, all right, for the updated value, you have the note that f of x2, if you substitute that, f of x2 is equals to 5.1290, and f prime of x2 is also equals to 38.0410. Okay, so now if you substitute these values into the function, we can say that iteration x3 will be equals to the value of x2, that is 3.0305 minus 5.1290 all over 38.0410. And that approximately gave us 2.895 and 7. Oh, wow. So we've gotten that. Okay. So if you also check for the absolute value of xn plus 1 minus xn is still not less than my epsilon value. So I will continue my iteration to x4. So x4 will be equals to x3 minus f of x3 all over f prime of x3. All right. Given that the updated value of x3 now into the function is going to be equals to 0 0.5, 0.5, 930. Then f prime of x3 also equals to 29.4380. Okay. If we substitute this value into the iteration formula, we have x4 to be equals to 2.8957 minus 0.5930 over 29.4380. So that approximately gave us the result of x4 to be equals to 2.875 and 6. And now we see the values are converging. if you compare the value of the x3, I mean, the x3, we got 2.8 and I think 9. Okay, but now, right now, we've gotten a convergence value of 2.8 face. First decimal place has converged. So I want to check the next value. That's my x5. So, and try to see if you try, I think the epsilon value now, if you check the difference, this one or that, we have approximately 0.0. So, but I said 0.01. So I will still have to try the updates and then check the final one and check for the next value. That means I think definitely this next value should give me what I want. So that will give me x4 minus f of x4 divided by f prime of x4. And the updated value of these values into the function is f of x4 is equals to 0.013275. All right. And then f prime of x4 is equals to, we check f prime of x4, that give me 28.2461. Substituting that into the iteration formula of x5, you have x5 will be equals to 2.8756 minus 0.013275 divided by 28.24 and 61. So that will also give you approximate value of about 2.87. I still have 5, then 1 there. Wow. Now check my, let me change the color of my pen. I want you to really see what I'm going to show you right now. Check this place and then check this place. They are the same. They've converged to my 3 decimal places according to what I choose. Wanted to use my epsilon value. So if you try the epsilon, this thing, you have that absolute value of my x5 minus my x4 is less than, check out, is less than 0.001. So I'm going to stop my iteration here because I've achieved my goals. So how do I conclude this? I will say, therefore, the value of the root of that problem, root of the function, root of f of x is equals to, is x equals to 2.87 and 5. 2.875. 2.875. That is my solution, and that is the solution to that function. I believe this video, this lesson has helped somebody already. Please don't forget to subscribe to this channel if you haven't done that already. And don't also fail to like and subscribe. It make my work boost out, please. And I promise you, what lesson to come is going to be amazing, and is going to find you on the proper spot where you belong in this field of mathematics. You remember, in this platform here, I'm going to share varieties of mathematical techniques in different fields of mathematics. It's not only calculus. People will want to say, why are you really emphasizing in different areas of mathematics? It's just where I see problems coming is where I step my foot in. So please, the summary of the whole service, do me a favor of subscribing to my channel. Thank you and have a nice day.